Starting with this first one here where we are adding the fractions together, what's the first thing we need to do when we're adding fractions? And this is actually the same thing for subtracting fractions. What's the first thing we need to do? We need a common denominator. All right, we cannot add fourths together with fifths because they're different. So we can only add them together if those denominators are the same. So what number do 4 and 5 both go into? 20? Okay. Is 20 the only number we could use for a common denominator? Let me ask this. Do 4 and 5 both go into, say, 40?
Yes.
Sure. They both go into 60. They both go into 80. So there's actually as many common denominators as we could possibly want. But this one is the lowest common denominator, so we'll use that one. That'll make things easiest. All right, so I need to make this 3/4 into something over 20. So these fourths are changing into 20ths. What do I do to do that, to get that 20 in the bottom? Multiply by 5. So if I multiply by 5 on the denominator, I have to multiply by 5 in the numerator on top. All right, and 3 times 5 is? 15. So 3/4 is the same thing as 15/20ths. All right, then we need to do the same thing with the 3/5. What do we do to what do we multiply by there to get 20 on the bottom? By 4. So we'll multiply by 4 on top and bottom. And 3 times 4 is 12. So we get 15 over 20 plus 12 over 20. Now that the denominators are the same, we can add 20ths together, right? So what do we get when we had 15 20ths plus 12 20ths? Now, what kind of fraction is that? It's an improper fraction. Is that okay? Yeah. We're going to leave this as an improper fraction. You do not need to change it to a mixed number. So that's your answer. We also need to get a common denominator for the second one. One way to get a common denominator, and this may be what you did in the first one, is just by multiplying these two denominators together. So like 4 times 5 gave us the 20 for the first one. We could do that here and do 8 times 12 and get 96 and use 96 as a denominator. I don't want to do it that way because 96 is bigger than we need. Does anybody know a smaller number that 12 and 8 both go into? Somebody say 2? 24. All right, remember, the denominators we're looking for are going to be bigger because, remember, we have to multiply 12 times something to get it and 8 times something to get it. So if you think about the numbers that 12 and 8 both go into, we're looking for numbers that are bigger than those. So like 12, 24, 36, 48. So 24 is going to be, well, it's going to work for both of them. So we're going to rewrite this one, something over 24 minus something over 24. And how do we change that 12 into a 24? Multiply by 2. 5 times 2 is 10. How do we change that 8 into a 24? Multiply by 3. 5 times 3 is 15. All right, now we can subtract. We subtract because the 10 is positive and the 15 is negative, right? So when we have 10 positives and 15 negatives, we're going to have some canceling going on, and what's going to be left over? 5, negative 5, right? So since there are more negatives, the 15 is the negative one. There's more negatives than positives, we get a negative answer. So it's going to be negative 5 over 24. And we've talked about this before. You can put the negative up on top with the 5, or where else could you put that negative? Yeah, you could put it out in front in the middle. Okay, it would not be okay to put the negative down in the bottom with the 24, though. All right, this is one thing you'll want to keep in mind. You never want to have a negative in the denominator. All right, so on this one, we're doing 12 times 3/4. What do we do if we have a whole number times a fraction? What's the first step there? Yeah, we're going to put a 1 underneath it. Now, this isn't even in the notes. The notes that we took are just for multiplying fractions, so the first thing we have to do is make sure they're both fractions. All right, now, when we're multiplying, what's the first step? I only see a few people with their notes out, but what does the first step say in the notes that we took? Reduce any numerator with any denominator. So if we're looking at the numerators would be the 12 and the 3. Do either one of those reduce with the 1 or the 4? The 4, right? We can never reduce a 1, but the 12 and the 4 can reduce, right? What goes into 12 that also goes into 4? 3 doesn't go into 4. 2 does. Okay, so let's reduce by 2. 12 divided by 2 is 6, and 4 divided by 2 is 2. Okay, is there anything else we can reduce?
6 and 3.
Can we reduce the 6 with the 3?
No. Yeah.
Why not?
No,
Because they're both in the numerator. So since they're both on top, we cannot reduce those. What about the 6 and the 2? Can we reduce that? Sure. In fact, when we did the 12 with the 4, we could have just reduced by 4 to begin with, right? Did some people do that? Yeah, if you did that, then you're going to save yourself a little bit of work. All right, now, I know right now there's nothing else that's going to reduce. How do I know that? It's not possible. Yeah, both of the numbers in the denominator are 1, and we know 1s are never going to reduce. So on top, now we multiply across. So on top we have 3 times 3, which is 9. And on the bottom we have 1 times 1, which is 1. And so we get 9 over 1. Is that your final answer? One thing we want to do is make sure we write our answers as simple as we can. Is there a simpler way to write 9 over 1? Just 9, right? So 9 over 1 means 9 divided by 1, and we all know that 9 divided by 1 is 9. So that's going to be your answer. All right? Anytime you get a number over 1, get rid of the 1. You don't need it. Okay? We did put a 1 in here with the 12 so that we can multiply the fractions, but if we get an answer with a 1 in the bottom, we want to simplify that. And the way we simplify that is just getting rid of the 1. When we are dividing fractions, there's a little trick that we have to do before we can really start. We can't actually divide fractions. We did see an example yesterday that we could actually divide the fraction, but in this case we would have to do 2 divided by 5 and 3 divided by 6, and that doesn't work. So we can't divide across, so we're going to have to change it to what kind of problem? Multiplication, exactly. So how do we change it to a multiplication problem? Okay, we're going to flip the 6 over 5. What's that little acronym that we use to remember what to do? The KFC, right? So K stands for what? Keep. F stands for, and C stands for? Okay, so keep, flip, change. So what are we going to keep the same? 2 over 3. What are we going to flip? The 5 over 6 becomes 6 over 5. What do we call it when we flip a fraction? What's that called? Starts with an R. Reciprocal, yes. So 6 over 5 is the reciprocal of 5 over 6. And then we change what? Yeah, change division to multiplication. All right. Now, you have to be careful. We always want to reduce, but don't reduce here before we flip it. Okay? We want to reduce down here. So is there anything now in the numerator, the 2 or the 6, that'll reduce with anything in the denominator, the 3 or the 5? There's one thing. What is it? The 3 and the 6, right? So what goes into 3 that also goes into 6? 3, right? 6 divided by 3 is 2, and 3 divided by 3 is 1. Okay, can I cancel the 2's here on top? Why not? Because they're both in the numerator. All right, so I can't reduce anything else, so the next thing I do is multiply across. All right, so we have 2 times 2, which is 4, and I have 1 times 5, which is 5. Now, could we get the right answer if we didn't reduce here in this step? Would we still be able to get the right answer? Yeah, we could. We would just have to reduce in the end. So let's look at that real quick. So after the KFC step, we had 2/3 times 6/5. If we just multiply across right now, we get 12 over what? 15. Is there anything that goes into 12 that also goes into 15? 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. Alright, so we didn't reduce here before we multiplied, but if we reduce in the end, if we reduce after we multiply, we still get the same answer, right? We still get 4/5 either way. Does that make sense? So it's okay if you don't reduce while you're multiplying, but you need to make sure you reduce in the end. If the numbers that you're multiplying are really big, it's probably better if you reduce first, because then you're going to get an even bigger number when you multiply them. And it's a lot harder to reduce big numbers than it is to reduce small numbers.